Hello, retro fans. This is not going to be a real episode. This is just some topic I'm working on, and I want to share some thoughts, ideas, whatsoever. But first thing first, Happy New Year! Welcome to 2022 or 2022 or whatsoever we want to call this. And yeah, I hope everything is working fine so far for you all out there. And you may have seen my Happy New Year clip on Twitter or YouTube. And I was using a C64, which is kind of transferring data to an Arduino and on a little display attached to the Arduino. I was kind of creating the message Happy New Year. This is actually not a very complicated task. You can do this quite quickly by using a couple of, let's say, libraries. But for me, it is a little bit, let's say, different because I have been interested in using the user port of the C64 for quite a long time, and I never really found a, let's say, good purpose or whatsoever idea what to do with it. But since I started to work with a, let's say, with home computers in the mid 80s or something like this, it always has some sort of fascinated me to control things outside of the computer. And my first attempt was to use the former GDR home computer, the KC84/3, because this unit has, it was available with a digital in-out interface. And since I have learned electronics in my apprenticeship, it was quite a short step to create some sort of an interface. And I did some things with it, controlling some lights and whatsoever, but not really fancy stuff. And it was somewhere, I think, in the mid-late 90s that I used this for some projects, but then I never really came back to this whole interface thing again. But as I said, with the C64, I was always interested in to use the user port to exchange data, control things outside the C64. And while working on something completely different, I came up with this one. And what I want to do today is I want to go into some details, what's important to pay attention to, how to establish this whole thing. And I want to try a couple of things, and hopefully the C64 as well as the Arduino is going to stay alive during this whole exercise. And since my whole video capture setup is still in some sort of development, it's probably going to be a little bit messy with scene changes and all that stuff, because I haven't set up my control interface to all the new scenes, and I'm still trying to sort out some things within OBS, because some things aren't working the way I want this, but I'm a little bit, let's say, not so motivated to work on the OBS side because I'll have to work on a couple of other things. Anyway, so without further ado, let's get into the topic and see what I have some sort of prepared for today. And as usual, let's start with a view on my desk. And here you can see I have the C64 board on my desk, and I have attached the Arduino with the display already. Trying to find a different angle so that you can see that something is going on. So actually it's not really, maybe let's bring this a little bit closer to the camera. That's not really rocket science what I'm doing here right now. My breadboard is dropping some things. And well, the C64 is actually running a basic program going through a loop and simply counting up a value. And this value is transferred via poke command to the control register of the CIA. And I'm using 8 bits, so it's a parallel mode. And I'm using a 9th bit to trigger an interrupt on the Arduino side. And every time I trigger this interrupt, the Arduino jumps into a routine and reads the related bits on the digital I/O ports. And every time I trigger an interrupt, the LED goes off or on respectively. And this is some sort of slowed down, so this can be increased in speed. But doing this with a basic program and doing this by a poke and manually set interrupts is probably not the most efficient way, since the C64 is able to utilize the user port as a Centronics interface, for example, which is a parallel interface. And there are libraries available for the Arduino which are enabling you to use the Centronics protocol for data transfer. So speed-wise, that's going to be a much more better option. But as I said, I'm more or less interested in the how to get this working approach and not so focused on efficiency and optimization. That's probably something I'm going to do later. And there are actually a couple of things to keep in mind if you connect Arduino hardware to the C64. And the most important thing is that I'm going to show you this as soon as I find the window. Here we go. This is actually the CIA on the C64, and here we can see the user port. This side, well, my mouse is gone. So that's probably one thing I have mentioned at the beginning. So let's see whether I can capture cursor. It's enabled, but it's not visible. That's pretty weird. Here we go. So this is actually the CIA responsible for communicating or controlling the user port. And what we can see here right now is that there's really a direct connection between the user port pins and the CIA pins. So there is nothing in between that would protect the CIA from external voltage and exceeding currents or something like this. So this is really, really important that you pay a lot of attention what you are doing outside the user port. And this brings us actually to the next topic, and this is basically the mode in which the CIA is actually working. So the CIA is able to use these digital pins, in-out pins, whatsoever you want to call this, in bidirectional mode. So it can push out, let's say, data, and it can receive data. And this is really important because this determines the, let's say, electrical behavior of those pins as well. So if we set the CIA to, let's say, an output mode, then the signal level is either high or low. So it's somewhere around 5 volts, a little bit less, and somewhere around 0 volts, depending on the on the high-low signal. And in this mode, you can, let's say, use the voltage outside the C64 and, for example, power an LED or something like this. And this may create the problem that you exceed the max, let's say, the max current provided by the CIA. And since there are no resistors or something like this in between, which would kind of limit the current, you may end up with well, broken CIA because you have exceeded the max current limits. And regarding the specs, the current limit is about 0.1 ampere or 100 milliampere per pin. And this is indeed a little bit very optimistic, because if you do this per pin and you're using, let's say, 8 pins, then you are very close to 1 ampere for the whole CIA. And that's probably not going to work. So it will heat up quite quickly, and it will exceed perhaps your, let's say, power supply as well. So that's not going to be a very good idea. But if we talk about, let's say, using electronics on the user port, then usually it is not the case that you draw so much current from it, and therefore it is not so critical at all. But you have to keep this in mind. There is actually a limit, and CIA kind of proven to be a very sensitive part in the C64, and therefore we really have to pay some attention. And the next thing is that if we're going to switch to the Arduino side, for example, we have those digital pins, so they are called, and you can define them as either output or as input pins. And what I have mentioned about the CIA is actually almost the same on this side. So we can configure whether we want to send data or if we want to receive data. And depending on this, we have a different behavior on the, well, let's say, electric side as well. And the interesting thing is that if we set the Arduino pins to input, then we have actually 2 different states. So we can just set them to input and do nothing more. Then they are some sort of floating. And that's quite interesting, because if you want to connect this to the C64 using the user port or the control port, then this is a good chance that you're not going to have any electric activity going on, since, well, the pin is floating. It is neither connected to ground nor to a 5 volt, for example, and therefore it is actually the safest state to connect devices to each other. And the next thing is that there is an integrated pull-up resistor inside the Arduino, and you can set the input to input pull-up, and then you have a defined, let's say, signal level on this input pin. But there's always a but. You have to keep in mind, if you configure the pin to input pull-up, then you set this pin to be on 5 volt. And depending on the configuration of your CIA pins, this can cause some current to flow from the Arduino side to the C64 or vice versa. And this is actually a little bit dangerous depending on the state the CIA is actually on. And even if it's not really related to the user port, but if we scroll up a little bit to the control ports, which we can see here, these are the so-called joystick ports or control ports. And especially control port 1 is connected to the same data lines our keyboard is using. And the CIA is basically switching states between reading and output data in order to get data from the keyboard. And if we set those data lines to 5 volt, for example, and the CIA is going to set these ports to outputs as well, then we have some sort of well, a collision, which is electrical speaking not correct, but just to kind of visualize this a little bit. And therefore it is really important that you never set those data lines to 5 volt or high level if you cannot ensure that the CIA isn't set to output mode. So this is really, really important. For CIA 1, I think, or 2, I always mess up the numbers. So this is called U2, so I guess that's CIA 2. It is some sort of easy because there is a register. You just write 2 and then you set those pins to either input or output. So you're on the safe side. But as I said, for the CIA 1, which is working with the keyboard and the control ports, you never know really in which state it is. You can read this from a register, but that's probably going to be too late if you have connected some external hardware already. So actually that's one consideration we have to keep in mind while connecting hardware to the C64. And the next thing I came up with is, let me switch back to my desk. There we go. Strange why this animation is still kicking in. If you work with the Arduino and you work on your programming, for example, then you kind of end up with the issue that you have to connect this Arduino to USB over and over again because it is actually absolutely not recommended to connect the Arduino to USB and keep the C64 connected as well, since the C64 is powered up by a different power supply. So you may end up with different ground levels, you may end up with different 5 volt levels, and especially if you connect the 5 volt of the Arduino to the 5 volt of the C64, that's probably going to cause a mess, since this 5 volts is created by different power supplies, and that's actually not really recommended. And I mean, you can bypass this a little bit by, let's say, not connecting the 5 volt of the Arduino to the C64. In this case, this constellation wouldn't work because now the Arduino is powered by the 5 volt of the C64. But if you connect this to USB, then you can disconnect this 5 volt and the Arduino is powered by USB. But you still have those ground on the C64 side and the Arduino side are connected to each other. And this is probably not going to be the very same ground. And we may go to test this and see if we can measure something like this. And what I had in mind is that as I started to make, let's say, some sound or music with the C64, I constantly run into the problem that either my capture cards or my sound capture devices started to create some humming or something like this because of those different voltage levels. And so I bought those USB interface whatsoever protector devices, and they split ground as well as 5-volt as well as the data lines from each other, or from interfering. It's a little bit hard to just explain. And what I'm going to do is I want to test this, whether I can still program my Arduino if I'm going to use those devices, because they kind of influence the USB behavior, and whether this is a good idea to connect the Arduino by using this device to my PC and keep it connected to the C64. So hopefully nothing is going up in flames, but as the very first thing, let's have a look inside this little thing. And as you can see, this is not just something simple. We have some sort of a couple of components inside. And the very first thing I'd like to test, and a little bit running out of space here on my desk. So let's test something else. Looks a little bit dirty, but probably going to do the trick. And let's switch off the C64. So, and the very first thing is actually checking if there's a connection between the input side and the output side. So we're using this digital measurement thingy. Just have to find some sort of an angle that you can still see something. Yeah, this may work. Okay. So let's check first ground. Nope, no connection. And then we can check the ground pins. Suppose like this one, there's nothing. And 5-volt, there's nothing. And the data lines, there's nothing as well. So we have an electrical separation between the input and the output side. And the next thing I'd like to do is actually checking whether we have a difference, let's say, on the ground side. So how to do this right now? So maybe let's use this as some sort of an adapter. Oops. So you can see I have connected this to my PC USB, and it's just signalizing that it is doing something. So let's go to this one, and then let's look for ground. And you can see there's a very small difference in voltage. So in an optimal world, it should be 0, because we want to have the same ground level all over the place. But since the may have, let's switch it to AC. See what's going on there. No, it looks even better. Yep, but we can see that there is indeed a difference in voltage on the DC side, because ground is coming from two different power supplies, and this may not work as good as expected. And yep, that's basically the first test I want to do. And the next test is we're going to disconnect this from the C64, which is some sort of cumbersome experience because those user port connectors are pretty tough. So then let's connect USB to our Arduino. Windows is saying there is something, and the Arduino has started as well. As we can see, it's doing nothing because it's not receiving anything. And now let's see if we can transfer some data to it. And I think it was this window. There we go. And let's say upload. And indeed, it is transferring data to the Arduino. It is blinking. It's coming back to life. So everything is working fine on this side. And the most interesting question is, I don't know, if it is going to work if we connect the C64 to it, or if we are going to see flames and smoke and whatsoever things. So let's connect this. So the Arduino has disconnected from Windows, so it looks like that this whole thing isn't working the way I want this. And I assume that this has to do with the 5-volt line. So let's see if we're going to disconnect this. Yep. So I think the tricky point here is that we haven't triggered an interrupt. I was just a little bit confused why the Arduino is stuck in the welcome message. Yeah, the thing is that these USB splitter device, interface, port protection, whatsoever we want to call this, I have really no idea how they are called. And they have to kind of separate the two worlds of the USB side on the PC and the device side, but they still have to provide power to the USB device you have connected to it. And since the power line, or the power line is perhaps a little bit too much to say, the 5-volt line of the Arduino was still connected to the C64. The C64 started to draw power from the USB device. And actually, the C64 board, even the newer revision, they require a little bit more than 0.5 amperes, so to say, which is actually the upper limit for a standard USB 2 connection, something like this. And therefore, the power supply for the Arduino dropped below a certain level, and the Arduino just kind of went into an undefined state. So assuming that the C64 is still working, let's see what happens if we're going to switch on power. And let's move to this view so that we can see the C64. So it is booting, and sooner or later we should get a signal as well. There we go. And I have prepared a small program to test this. So, typo, yep, indeed, I have some sort of version numbers here as well. Here we go. We're going to start this. We can see our Arduino started to represent the data we are feeding into it via the USB port, the user port. And to me, it looks like this is a setup. This is probably going to work. And what I never really understand is why this 1541 Ultimate 2 Plus isn't stop spinning the disk. See if we can read the directory. Now it kind of went into a undefined state. Okay. But our basic program is still here. So while we are here already, let's have a quick look at the basic program. And as you can see, this is as simple as it can be. The very first thing, and this is really important, is set the port bits to output, because then they are electrical wise less sensitive to any well, mistakes you may do on the outside. And then I set this PA2 pin to output as well, since there are 2 ports on the CIA. And then I just created this loop from 0 to 255. And then I set the output byte, the port byte, to this value. And then with this next line, I just trigger the interrupt, as I have mentioned before, by setting pin or mouse signal line PA to high and then back to low. And this triggers the interrupt on the Arduino side, and then it reads the signal on the port. And then I have this 4y equals 0 to 99 is just a pause loop to slow down the whole process. And then I go through this whole thing over and over again. So actually we have accomplished to run this on the C64 side. There's nothing to see because there's no output. But we have this on the Arduino. So if we jump back here, it's funny. I really have to figure out what's triggering this animation. And yeah, as we can see, it is counting. And just for the sake of this exercise, let's see if we go to this view and enable this as well. That's the C64 side, which isn't that much entertaining, because I was looking for this view. And just have to pull this down here a little bit so we can see the desk as well. And let's see if we can still upload data to the Arduino. So it's actually receiving data. And now it should start and start counting again. And everything is actually working fine. So anyway, so that's actually the whole thing about this little exercise or this little episode. And well, I will keep you informed about the next steps I'm going to work on. As I have mentioned, this is just some sort of a side project, and I did this just for the purpose of testing whether this is working in a way I have in mind. But actually I'm aiming for something completely different, which I don't want to mention here right now, since it isn't in a state that I want to talk about this, since I'm still learning a lot about Arduino programming and all this communication stuff, and therefore it will take a couple of more days, weeks, whatsoever, until I'm going to jump out with this. So anyway, as usual, thank you very much for watching, and thank you very much for any ideas and comments and suggestions in advance. Feel free to use the comment section if you have suggestions or questions or something like this. And a very big thank you to all of my supporters, whether you have joined the YouTube channel membership or on Patreon, or if you have contributed something to the channel. So many thanks to Adam. Your contribution is still waiting to be used. It's still in reach, and I have started to work on this as well, and hopefully soon we will see in the episode related to this topic as well. And well, stay healthy and have a nice start into 2022. Thanks a lot. See you later. Bye bye.